Hi my dear students, welcome back to the class. We were discussing about sets, isn't it? We discussed lots of things about set, and in the final class we discussed about operations we can apply on set, that is the union of two sets, intersection of two sets, etc. And we found out that it's very interesting to find the union of sets, which is the set of all elements which belongs to either of the sets, or the intersection of the set, which means the set of all elements which belongs to both the set, etc. Now in this session we are going to deal with some practical problems that we can apply the concept of sets into our daily life. So without any further intro, we shall begin the concept. Suppose that I am provided with a Venn diagram like this. Let this be our universal set and let this be the two sets A and B. Now suppose that the same Venn diagram, universal set, is drawn like this, and suppose that this is my two sets A and B. What is the difference between the first Venn diagram and the second Venn diagram? Yes, in the first Venn diagram there is a common portion, and in the second Venn diagram the common portion between the two sets is empty, which means that these two sets are connected, whereas these two sets is disjoint sets. And in this case we say that A intersection B is nothing but phi. In this case we can say that A intersection B not equal to phi, because A intersection B contains some elements here, hence it cannot be phi. So this is the two cases. Now observe that we know that A union B contains all elements, set of all x, such that x element of A or x element of B, isn't it? So if the sets are disjoint, which means that there is no common element in both the set, then we can see that number of elements in A union B is nothing but what? Number of elements in A plus number of elements in B, because there is no common elements in both. So A union B contains all the elements in A and all the elements in B, which means that number of elements in A union B is nothing but n of A plus n of B. Eppozhana? When A intersection B is equal to phi, or when the sets are disjoint. In that case we can say that n of A union B equal to n of A plus n of B. Now the question is, what happens when the intersection of these two sets not equal to phi, or the sets are not disjoint? What will be the answer? See, when we calculate n of A union B in this case, we can see that n of A union B contains all the elements in the set A and all the elements in the set B. Also we know that we will omit the repeated terms like that. See, n of A union B contains all the elements in set A and all the elements in set B, isn't it? Now you can observe that whenever we can take n of A plus n of B like this. Now while calculating n of A and calculating n of B, we count this portion twice, isn't it? See, it is contained in A and it is contained in B. So while calculating n of A and the n of B and taking the sum n of A plus n of B, we are actually calculating this area twice. So we have to subtract this area once. So the result will be minus n of A intersection B. Why? Because നമ്മൾ n of A plus n of B എടുക്കുമ്പോൾ we are adding n of A intersection B, number of elements in this area, 2 times, isn't it? So we have to subtract 1 time from this n of A plus n of B, this quotient, so that the exact answer will be n of A union B is equal to n of A plus n of B minus n of A intersection B. Let me once again explain the two concepts. Whenever these two sets are disjoint, n of A union B is nothing but n of A plus n of B. We know that A union B contains all the elements in set A and all the elements in set B. Now whenever the two sets are not disjoint, or the intersection of those two sets contains some elements, then we can see that n of A plus n of b. While calculating n of a plus n of b, we are adding this area twice. So we have to subtract this area ones from the sum so that the answer will be n of a plus n of b minus n of a intersection b. So now we know that n of a union b, which means that the number of elements in a union b is nothing but number of elements in a plus number of elements in b minus number of elements in a intersection b. We derived this using our logic from the Venn diagram, isn't it? We can derive the same result formally. Suppose that let a and b be any two finite sets. So we are going to prove the result. So let a and b be any two finite sets. Then we can draw the Venn diagram of a and b be like this, isn't it? If these two sets are disjoint, then clearly a intersection b will be 0. So n of a intersection b will be 0. So we get n of a union b is equal to n of a plus n of b, isn't it? Just keep in mind that's a special case of this proof. Okay. Now let a and b be any two finite sets. So we can have if a intersection b if equal to phi, then what? N of a union b will be nothing but n of a plus n of b. This result is very important. If a intersection b is equal to phi, then clearly n of a union b is equal to n of a plus n of b. Let it be there. Suppose that n of a intersection b not equal to phi. Okay, then you can see that this area is nothing but a minus b, isn't it? And suppose that this area is nothing but b minus a, isn't it? And this area is equal to a intersection b. So we have this area is nothing but a minus b, this area is b minus a, and this area is a intersection b. Also you can note that a minus b is this and a intersection b is this. So we can see that a intersection b and a minus b are disjoint set, isn't it? Similarly, b minus a and a intersection b, because they don't have any common element. B minus a is this portion, a intersection b is this portion, hence they don't have any common element in it. So a intersection b and b minus a are also disjoint sets. Now suppose that n of a union b can be written as, see, a union b include all the elements or all the elements in the entire diagram. See, all the elements in this set. So n of a union b will be n of a minus b plus n of a intersection b plus n of b minus a. Why? If the sets are disjoint, then n of a union b will be the sum of the number of elements in each set, isn't it? We already proved that if a intersection b equal to phi, then n of a union b is equal to n of a plus n of b, isn't it? Here the intersection of a minus b and a intersection b are is equal to phi, b minus a and a intersection b again equal to phi. So we know that n of a union b will be the sum of the individual sets, the sum of number of elements in the individual sets, isn't it? So sum of elements in a minus b plus sum of elements in b minus a plus sum of elements in a intersection b. So that will be what? Our a number of elements in a union b then. Now you can add and subtract. Let me add and subtract n of a intersection b in this expression. This does not change the equation, since n of a intersection b minus n of a intersection will be a intersection b will be 0. So this won't make any change. I just added and subtracted n of a intersection b in order to make a more convenient calculation. Now let us associate the quantities. Let n of a minus b plus n of a intersection b. Let them stand together. So I associated these two terms together. Now I am going to associate these two terms also together, plus n of b minus a plus n of a intersection b minus n of a intersection b. So what I have done is I just added these two terms, added and subtracted n of a intersection b at first. Then I just associated this term this term, and finally this will remain here. Okay, now you can observe that n of a minus b plus n of a intersection b. What is a minus b? A minus b is this portion and a intersection b is this portion. So when we add them together, we will get the entire set A, isn't it? So this will be nothing but what? N of A. Similarly, b minus a is this portion and a intersection b is this portion. So when we add, we will get this portion, the entire set B in this case, plus what is this then? N of B minus n of a intersection B. So we get the final answer or the final result as what? N of a union B is equal to n of a plus n of b minus n of a intersection B. Always remember that what we have done in the first step is we just considered a union B. We know that a union B is the entire set, isn't it? Okay, and then we considered three sets. What are those three sets? A minus b, a intersection b, and b minus a. We know that these three sets are disjoint since they does not contain any common element in it, isn't it? So the number of elements in A union B will be the sum of number of elements in this set plus this set plus this set. That is what we have written in the first step. Then we have added and subtracted this quantity. We know that there will be no change if we add the same number and subtract the same in an expression, isn't it? So I just done this operation here and I associated them to get a new quantity, and finally I obtained n of a union B is equal to nothing but n of a plus n of b minus n of a intersection B. Therefore, we formally derived or we gave a formal proof to the result n of a union B, which means number of elements in a union B as number of elements in A plus number of elements in B minus number of elements in A intersection B, isn't it? Now the question is, what happens if more than two sets are occurred? For example, suppose that we are provided with three sets, isn't it? Suppose that we are provided with three sets A, B. Let A, B and C be three finite sets. Then we have to find the formula for n of A union B union C. So this is now our objective. If we are able to derive this, then we can derive for the case of 4 sets, the case of 5 sets, etc. It's very simple, just like this format. But in our topic, we have to find out n of A union B and n of A union B union C. These two formulas are very important. Now we are going to derive the formula or the equation or the expression to find number of elements in A union B union C, where A, B and C are any three arbitrary finite sets. Okay, we already derived the formula for two arbitrary finite sets. Now we can use this expression in order to derive the formula for this. Suppose that we have to find n of A union B union C, isn't it? Now I am considering this set B union C as a single set. Then this case will be the case of union of two sets, isn't it? We know the expression, we know the formula to find the number of elements in the union of two sets as n of A plus, and this set is B union C is now considered as a single set, then n of B union C minus, we know that n of A plus n of B minus the intersection n of A intersection B union C, since B union C is now considered as a single set. So this is it. So this is our equation number 1. Now in equation number 1, we are now going to find out n of B union C. We know the formula for finding the number of elements in a set in the union of two sets, isn't it? As n of B union C is nothing but n of B plus n of C minus n of B intersection C. Let this be our equation number 2. Now we are going to evaluate this quantity. What is that? N of A intersection B union C. So we are going to find this quantity, but we know that this is very important. A intersection B union C is nothing but A intersection B union A intersection C. Do you remember this result? This property is known as the distributive property. Now you know distributive property. So using distributive property, we can have, this is nothing but n of what? A intersection B union A intersection C. Why? Because by distributive property, this quantity is nothing but A intersection B union A intersection C. So this will be this. Now consider this as a single set and this quantity A intersection C as a single set. Then this case also reduces to the union of two sets, isn't it? We know the formula as n of the first set A intersection B plus n of the second set A intersection C minus n of intersection of the two sets A intersection B intersection A intersection C. So this will be our new case, isn't it? So this is our required state. Now we are going to evaluate this quantity. So this is our equation number 3. Now in order to evaluate this quantity, we now require the support of a Venn diagram. Suppose that this is our Venn diagram and we are provided with 3 sets like this. You know that our now our case is about 3 sets A and B and C. So this is our set A, this is our set B and this is our set C. Now we want to find out A intersection B intersection A intersection C, isn't it? What is A intersection B? This area is A intersection B. What is B A intersection C? A C. Right? So A intersection C, this area will be A intersection C. What is A intersection B intersection A intersection C? That is the common part of this area and this area, which is this small area, isn't it? And that small area is nothing but what? A intersection B intersection C, isn't it? The intersection of 3 sets is this small area. So this quantity is nothing but what? We know, we get A intersection B intersection A intersection C is nothing but what? A intersection B intersection C. So we are going to substitute this result in equation number 3. Substituting in equation number 3, we will get n of A intersection B union C is equal to n of A intersection B plus n of A intersection C minus n of A intersection B intersection C. Why? Because this quantity is nothing but A intersection B intersection C. So we obtained this. So this is now our equation number A. Now we are going to substitute equation number A in equation number 1 and equation number 2 also in equation number 1. So we are going to substitute this equation and this equation in this equation to get the final answer. Now we shall substitute those quantities in equation number 1 to get n of A union B union C is equal to, we have n of A here, n of A plus, and instead of n of B union C, we already derived a new thing. What is it? N of B plus n of C minus n of B intersection C, isn't it? N of B plus n of C minus n of B intersection C. Now what is next? Next thing is minus what? N of A intersection B union C. But we already derived n of A intersection B union C is this quantity. So we can substitute all of these things. N of A intersection B plus n of A intersection C minus n of A intersection B intersection C. So we substituted all those quantities into the equation number 1. Now we can simplify this result into n of A plus n of B plus n of C minus n of, we are going to write A intersection B first, n of A intersection B. Now we are going to write B intersection C minus n of B intersection C. Now we are going to write minus n of A intersection C minus n of A intersection C. Now minus into minus will be plus n of A intersection B intersection C. So this will be n of A union B union C. What is the result? N of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C will be the number of elements in the union of any three arbitrary finite sets. Remember that it is for, these equations are for finite sets. Now we shall do example number 23 of your textbook. The question is, if x and y are two sets such that x union y has 50 elements, x has 28 elements, y has 32 elements, how many elements does x intersection y has? So this is our question, and we know that whenever x and y are two arbitrary finite set, we know the formula n of x union y is nothing but n of x plus n of y plus minus n of x intersection y. So this is our formula, and we are asked to find out, always look into the question and identify what we have to find out. Here we have to find out how many elements does x intersection y has, which means that we have to find out n of x intersection y, isn't it? So all other things we are given with number of elements in x union y. So this is given, number of elements in x, so this is given, and number of elements in y, so this is also given. So all other things are given, so we can isolate n of x intersection y in the any one of the side, or in the right side or in the left side. So I am going to keep this term here. So all other terms will come to here, n of x union y minus n of x minus n of y will be equal to minus n of x intersection y, isn't it? Now I am substituting the given values. N of x union y is equal to 50 minus n of x is equal to 28 minus n of y is equal to 32 is equal to minus n of x intersection y. And on calculating these things, we will get 50 minus 60, which is equal to minus 10 is equal to n of x intersection y. Therefore, minus n of x intersection y, which implies number of elements in x intersection y is equal to 10. So this is the way to deal with such problems. Now we shall move on to example 24 of your mathematics textbook. The question is, in a school there are 20 teachers who teach mathematics or physics, and of these 12 teach mathematics and 4 teach both physics and mathematics. How many teach physics? This is the question. So let me first of all do this thing. Let capital P denote the set of all teachers who teach physics, and let capital M denote the set of all teachers who teach mathematics. So I named both the sets. So looking into the question, we are given with, always remember this tip, whenever or is used in this question, in such questions, just remember that it denotes or it means union of those two sets, and whenever and is used in between those two sets, it means that intersection of two sets. In almost 90% of the problems this will work. What? Whenever we can see an or, it may mean union, and whenever we are provided with and in between the two sets, it means intersection. Okay, now so in in that context, we can read the question as, in a school there are 20 teachers who teach mathematics or physics, which means that n of P union M will be what? 20. Now of these 12 teach mathematics, which means that n of m is equal to 12. And 4 teach both physics and mathematics. Then we have n of p intersection m. Both teach physics and mathematics. So it will be what? 4. Therefore, now we are asked to find out n of p, isn't it? Number of teachers who teach physics. We know the formula. N of p union m is equal to n of p plus n of m minus n of p intersection m, isn't it? Now we can substitute the given quantities. So it will become 20 is equal to n of p plus what is n of m? 12, isn't it? 12 minus what is n of p intersection m? 4. So 4 will be the answer. So what we have, n of p will be 20 minus 12 minus 4 will be 8, and when it goes to left side it will be 20 minus 8. So the answer will be 12. Therefore, there are 12 teachers in that school who teach physics. Now we shall do example number 25 of your textbook. The question is, in a class of 35 students, 24 like to play cricket, 16 like to play football. Also, each student likes to play at least one of the two games. How many students like to play both cricket and football? Okay, now you are able to identify what things we have given with and what is asked. You can easily identify the and here. So it will be intersection. Also, here note that also each students like to play at least one of the two games, which means union here, because we know that the union of two sets is the set of all elements which is contained or which is included in at least one of the sets, isn't it? So here at least implies the union. Total number of students is 35. Let me first of all name the set of all students like to play cricket as C, and set of all students like to play football as F. So this is the set of all students who likes to play cricket, and this is a set of all students who likes to play football. Now the total students in this class is 35, isn't it? So there are 35 students who likes to play at least one of the two games. You should read like this. There are 35 students who likes to play at least one of the two games, which means that n of C union F is nothing but what? 35. Now 24 like to play cricket, which means that n of C is equal to what? 24. 16 likes to play football, which means that n of F is what? 16, isn't it? Therefore, we are asked to find how many students like to play both, which means that we are asked to find n of C intersection F, isn't it? Now we know the formula. N of C union F is equal to n of C plus n of F minus n of C intersection F. Now we shall substitute all the given things into this expression, which means that 35 is equal to 24 plus 16 minus n of C intersection F. Therefore, n of C intersection F is equal to 24 plus 16, which is what is 24 plus 16 equal to 40. 40 minus 35, which is equal to 5. Therefore, there are 5 students who likes to play both cricket and football. Now, coming on to example number 26. In a survey of 400 students in a school, 100 were listed as taking apple juice, 150 were listed as taking orange juice, and 75 were listed as taking both apple as well as orange juice. We are asked to find the number of students who taking neither apple nor orange juice. So this is a little bit tricky question. Suppose that we are giving the name A for the set of all students or set of all people who take apple juice, and O for denote in order to denote the set of all students who take orange juice. Then according to the given information, we can have 100 were listed as taking apple juice, which means N of A will be what? 100. Now 150 were listed as taking orange juice, therefore N of B will be what? 150. Now the next, 75 were listed as taking both apple as well as orange juice, therefore N of A intersection B will be 75. So these all things are provided. Now the survey is conducted among 400 students, therefore number of elements in the universal set. The universal set is in this survey is nothing but the set of all 400 students, isn't it? Which include all the sets under this survey. Is it? So N of U is nothing but what? The number of elements in the universal set, and it is nothing but 400. Now using this information we can easily find N of A union B. What is that? N of A plus N of B minus N of A intersection B. Now we are substituting the given things. 100 plus 150 minus 75, which is equal to 250 minus 75. Sorry. Which is equal to 175. So this will be what? N of A union B. Now we are asked to find the number of students taking neither apple nor orange juice, isn't it? A union B means those students taking apple or orange juice, either apple or orange juice, isn't it? So this is nothing but the complement of A union B. See, A union B denotes the number of students who are taking either apple or orange juice. We are asked to find those students taking neither apple nor orange juice. So the given event or the given statement will be the complement of A union B. So we are asked to find A union B the whole complement, isn't it? So we want to find N of A union B complement, which is equal to, we just subtract the A union B from universal set. We know that A union B complement is nothing but U minus A union B, isn't it? So N of A union B complement will be N of U minus N of A union B, isn't it? So we will get N of U minus N of A union B. Now what is N of U? It is equal to 400 minus what is N of A union B? It is equal to 175, and the answer there will be 225. Therefore 225 students are there who is neither taking apple nor orange juice. Now coming on to the 27th question. The question is, there are 200 individuals with a skin disorder. 120 had been exposed with the chemical C1, 50 to the chemical C2 and 30 to both chemical C1 and C2. Therefore, we are asked to find the number of individuals who exposed with C1 but not C2, C2 but not C1 and C1 or C2. First of all, let C1 denote the set of all individuals exposed with chemical C1, and similarly C2 denote the set of all individuals exposed with chemical C2. Let us draw the Venn diagram of this event as, let this be C1 and let this be C2. So C1 and C2. Now we are writing the given information from the question. We are given that there are 200 individuals with a skin disorder, which means that the universal set contains 200 members, right? Now 120 had been exposed with chemical C1, which means that N of C1 is equal to what? 120. Now the next condition is 50 to the chemical C2, which means that N of C2 is equal to 50. Now the last condition from the given question is that 30 of the students are exposed to both chemical C1 and C2, which means that N of C1 intersection C2 is nothing but what? 30. So we obtained several conditions or several given conditions from the question. Now we are asked that the number of individuals who are exposed to C1 but not C2. See, this is the event C1 and this is the event C2. C1 but not C2, actually what is that? C1 minus C2. So this is the set which denotes C1 but not C2. So we have C1 minus C2 is the area in the Venn diagram marked like this, and we know that C1 minus C2 union C1 intersection C2 is nothing but the set C1 itself. You can see from the figure itself, C1 minus C2 union this intersection is actually set C1 itself. Also note that the intersection, these two sets are disjoint. C1 minus C2 is this and the intersection is this. So these two sets are actually what? Disjoint. Therefore we have n of C1 is nothing but n of C1 minus C2 plus n of C1 intersection C2. Why? Because these two sets are disjoint as well as the union will give C1. We know the property n of A union B is equal to n of A plus n of B if A intersection B is equal to 5. Isn't it? See, here the intersection of this set and this set is actually what? 5, because C1 minus C2 is this area and the intersection is this area. So the intersection of these two set will be 5. Also union will be given as C1, the entire circle, isn't it? That's why we written like this. Now we can easily find n of C1 minus C2 is equal to n of C1 minus n of C1 intersection C2. What is n of C1 from the given condition? Equal to 120 minus the intersection is nothing but 30. So the answer will be 90 for the first question. Now the next, C2 but not C1. So we have to find n of C2 minus C1. Similarly, we can observe that C2 minus C1 union C2 intersection C1 is nothing but C2. That is, C2 minus C1 is this area and the intersection is this area. So the union will be given the entire circle C2, isn't it? Therefore, n of C2 minus C1. Similarly, like this we get n of C2 minus n of C2 intersection C1. Why? Because we know that by this result n of C2 is nothing but n of this plus n of this, just like this. So we just used the property this here also, because the two things C2 minus C1 and C1 minus C2 just looks alike unless the change in C1 and C2. So we just replaced C1 by C2 here, that's all. So what we can substitute is, what is n of C2? Here it is 50 minus what is n of C2 intersection C1. Note that C1 intersection C2 and C2 intersection C1 are exactly the same. So we will get 30. So the answer here will be 20. So the answer, those number of people is exposed with C2 but not C1 is nothing but 20. Now the last part. What is the last part? C1 or C2. As I have told you earlier, or denotes union. So we have to find n of C1 union C2. It is equal to n of C1 plus n of C2 minus n of C1 intersection C2. What is n of C1? N of C1 is given by 120. N of C2 is given by 50 plus 50 minus intersection equal to 30. So 170 minus 30, it is equal to 140. So the number of people who are exposed either with the C1 or with the C2 is nothing but what? 140. So that's the end of this session. I hope you understood all these concepts very well. If you have any doubt regarding these problems, because these problems are very important in the sense these are the practical applications of the chapter sets. So if you have any doubt regarding this concept, you can ask me, and make sure that you are very well clarified with these concepts. So in the next class we will solve the last exercise of this chapter. So wait for the next class. Until then, bye bye.